Alright guys, welcome to this set of videos. All of these videos are going to follow along with the notes that come out of Chapter 3, Section 4 of your Algebra 2 textbook. And if you don't have the textbook, what we're actually doing here in Section 4 of Chapter 3 is we're going to be solving systems of equations, but this time we're going to be solving systems that have three equations. And the reason we have three equations is because you're going to have three unknowns. Now, before we get into doing these problems, let me give you a couple of objectives or learning targets, things that you should know how to do by the time we get to the end of this set of notes. First, we're going to learn how to solve these systems of three equations, a system of equations with three variables. And then what we're going to do, very similar to when we did systems of equations with two variables, at the end of that set of notes, that end of those videos, I did a couple of word problems. Well, we're going to do the exact same thing here. You'll need to be able to take a word problem that I give you, pull the important information out of the word problem to write your own equations, and then of course from there solve those equations. But before we get to that, first we need to just figure out how we're going to solve these guys. Alright, let me slide this guy up for you, and I got a couple of things I want to talk about with you before we jump into it. First of all, it bears mentioning again, in order to solve a system of equations, if I have three variables, I must have three equations. I said earlier that in order to solve a system, the number of variables must match the number of equations. And what we're going to have is three variables, x, y, and z. Because you now have three variables, you must have three equations in order to solve for each of those variables. So, three equations, three variables. Now, the way that we're going to solve these equations is very similar to what we did with systems of two equations. We'll use both substitution. In limited circumstances, we'll use substitution. The vast majority of the time, it's going to be elimination, and not just elimination, but actually multiplication and elimination. These problems do get pretty tricky. We'll talk about that in a second. One last thing to note here about the solution. Your solution is actually going to be what we call an ordered triple. The reason it's an ordered triple, you have three variables, x, y, and z. Now, I'm sorry, it doesn't have to be an x, y, and z. Most of the time it'll be an x, y, and z. But whatever the variables are, you would have three of them, and so we will make them an ordered triple. Now, before we actually take a look at solving some of these, now is as good a time as any to make a quick note here to you guys, and it is this. There's really no nice way to put this. These problems are long. They are incredibly complicated. What that means is that the risk of you starting the problem, and if you're someone who generally doesn't show work, or you're someone who your work doesn't really have a nice orderly flow to it, you're just kind of throwing stuff all over the place, these problems are not going to go well for you. These problems are long, they are complicated, and if you are not clear in showing your work and sort of your progress through the problem, you're probably going to get lost. And because your work is not in any discernible order, once you get lost, you have no way of going back and finding your place. So, here's what I would tell you. These problems are long and complicated. These problems are long. And instead of saying complicated, what does complicated mean? Here's what I mean by complicated. They're long problems with many steps, all right? This is not like do a couple of steps and you've got your answer, all right? We're going to be performing several steps of work in order to get our solution, and it's easy to get lost in those steps. So these problems are long with many steps. To find solutions. All right, so here's what I would suggest. A couple of things. First, go slow. If you are taking this class with me on my test, these problems are going to be on there. But I know they're long, and I know that they take a while if you're going slow to avoid making mistakes. So here's what I would tell you. Obviously, you get faster with practice. So practice, 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 okay? You do need to be, you can't take forever on these, right? If it takes you 15 minutes to solve one of these, you're spending way too much time, right? Should be able to solve one of these in a couple of minutes. That's how you know that you're getting to decent speed, but being able to solve it in a couple of minutes accurately, and that just takes practice. After that, I would say, show all your work. Oh, I'm sorry. I'm not writing in Sanskrit here. We want English. Show all your work. Now, for some of you, this is going to be a little tricky. You're not used to showing your work, and this is where that's really going to hurt you. If you are not showing your work in these problems, you are going to get lost, and because you have not shown your work, you're not going to know where to go back to. You're going to wind up having to start all over from the beginning, and you will have wasted an enormous amount of time, and it's just going to be hard on you. So please, if you have not been showing your work, these are the problems to show your work on. And then the last thing I would say is this. As we do these problems, we're going to wind up with more than 3 equations. That's how complicated these are. We need to number those equations. Number all of your equations. By numbering the equations, it'll help you keep track of them and hopefully help you when it comes to solving these problems. Now, I don't want to scare you. Well, hopefully I haven't scared you. I love these problems. Solving systems with 3 equations, I actually almost find it therapeutic, and I know that that makes me a crazy person, but man, I love these problems. I like just sort of the flow to them. As we do a couple of them, you'll begin to recognize that there is a logical way to work yourself through these problems, and it's almost the same logical path every time. Very few exceptions where you can kind of shorten it, and shortcuts here and there you can take, and we'll talk about those. But man, I really, really do enjoy these problems. And as long as you do these things, go slow, show your work, number all of your equations, you will find quite a bit of success doing these problems. And believe me, with as much work as they require, by the time you get to the end of it and you get the right answer, there's not many feelings quite like it. That sense of accomplishment of having done something this tricky and doing it right. It's amazing. Now, before we get to doing any of the problems, I do want to talk about the types of solutions that you can get. So right here on the next page of the notes, we talk about the different kinds of solutions. Again, there are 3 possibilities. Just like with systems of 2 equations, systems of 3 equations, there are 3 possibilities. I can have an ordered triple, a single solution. So this would be one solution. Which would be an ordered triple, x, y, z. It represents the point where these equations intersect. Now, an equation with 2 variables in it represents, an equation with 2 variables both raised to the first power represents a linear function, a line. An equation with 3 variables in it, where all 3 variables are raised to the first power, represents a plane. And you should remember planes from geometry. So actually what would be happening here, and why I don't ask you to graph them, we are only going to do these algebraically, is you would be graphing a plane and you'd be looking for the point of intersection for those 3 planes. But here's what can happen with planes. It is entirely possible to have your planes oriented in such a way that they do not meet at a single point, but instead those 3 planes intersect each other in actually what is known as a line. Or all 3 planes turn out to be the exact same plane. Well, this is where you have an infinite number of solutions. And of course, if you wind up with an infinite number of solutions, what that means for us when we're doing these problems algebraically is I do all that work and I wind up getting a true statement. Remember, what will happen is the variables will drop out and I'll be left with a statement that's always true. 0 is equal to 0. -7 is equal to -7, right? Something that's always true. And then your third option, since it's 3 planes, is I wind up with a situation where those 3 planes, you don't have an intersection of all 3 planes. Maybe you only have 2 planes that intersect. Like here as well, both this one and this one, you only wind up with 2 planes actually intersecting. There's never an intersection of all 3. Or all 3 planes are parallel to each other and they never, none of them ever intersect. In any of those cases, this is a situation where you have no solution. And again, remember, algebraically, what this means is you'll do all the math, the variables will drop out, and you'll be left with a statement that is false. So there we go. These are the kinds of solutions that you can expect to get from a system of 3 equations where you have 3 unknowns. Now, what I've done right here is I just quickly give you a brief description, both of an example of the kind of problems we're about to do, systems of 3 equations. I've got 3 equations. Everybody's got 3 variables. I know it looks complicated and it's going to take a little bit longer to solve these problems, but again, we'll get through it together. You'll be fine. And I give you a brief description of kind of how I'm going to go about doing that, but talking about it before we actually do one, I don't think is going to do you any good. So, after we go through a couple of these, you'll come back and read this and be like, oh yeah, okay, I see it. But let's just go ahead and jump right into them. So if you head on over to the next page of the notes, we'll take a look at our first problem with a system of 3 equations, and I'll meet you there.